Okay, we're going to recap a type of problem that we saw in our homework, but we're going to break this up a little bit more so that we're not doing many steps all at once. In this problem, we are given a few different radii. So you got the planet, here's the mass, there's its radius. Let's draw that. The planet and its radius is 2 times 10 to the 6. And then you've got a star that's bigger. It has a bigger mass and a bigger radius, 4 times 10 to the 8 meters. Meters over here too. And then they tell us the distance between their surfaces is 6 times 10 to the 11. So Newton's law of universal gravitation says that these objects are attracted, and the equation there for their force of attraction, the gravitational attraction, is this. We also are familiar with this equation, and this equation, and then there's the speed equals 2 pi r over t. And the thing I want to point out is that each equation has an r in it, and every single r is the same exact thing. It's the distance from the center of one object to the center of the other. So how do I get that total distance? I have these 3 subdistances. Well, to get the total r, and I like to do this as a separate step, we add the 3 values. Here's the first one, here's the second one, and here's the first. And when we do that, we're going to have 10, 9, 8, 7, and 6 times 10 to the 11 meters. And that's the r that we use in every single equation. So for part A, we have to use the force, we have to calculate the force of gravity. And I've got the equation up there in the corner. Force of gravity equals big G. That's 6.67 times 10 to the minus 11. And then I have the product of the masses. Let me look back up. So the first mass is 5 times 10 to the 24. That's the planet. The second mass is 3 times 10 to the 30. And I divide by the distance between their centers squared, and that's the value I already found, 6.00402 times 10 to the 11 squared. When I plug this into the calculator, what do we get? 6.67 second EE, negative 11, times 5 second EE 24, times 3 second EE 30, over 6.00402 second E 11. And the great thing about the second EE button, is you don't need to put parentheses around the entire radius. You just plug it in like this, and you hit enter, and there's our answer, 2.78 times 10 to the 21 newtons. Okay, in part B, now that we've found the force, we're asked to find the acceleration. We know net force is mass times acceleration, and when something is in orbit, the only force it feels is gravity. So the net force is that 2.77, but we use the unrounded value that we calculated before. What mass do we use? Well, we're finding the acceleration of the planet, so we have to use the mass of the planet. That would be 5 times 10 to the 24. When we calculate, I'm going to see how I've got nothing in, and I hit divided by, and it automatically divides the prior answer. So I'm dividing by 5e 24. 5.55 times 10 to the minus 4 is my acceleration. Meters per second squared. In part C, we are asked to calculate the speed. If we know acceleration and we know r, we can find speed. I'm going to isolate v first, so I'm going to get it by itself. First I multiply both sides by r, then I square root both sides. So what do I have to plug in? Well, I have to plug in the acceleration from above, and I do the entire unrounded value, and I multiply by radius, and again, as always, we use the entire full radius, the same value that we calculated above. And in my calculator, I do second square root. I'm going to do 6.004020, second EE, second EE11, and I want to multiply by this value that's above, so I'm just going to do second minus to get the answer in my calculator, and I hit enter. That's 18,300 when we round. Meters per second for speed. In part D, we have to find the period. So we know the speed. We're going to calculate period, capital T, using speed v and radius r. First I'm going to isolate t and figure out what my equation should be. So I'm going to multiply both sides by t. Then what I'm going to do is I need to isolate t here, so I have to get rid of the v, and I divide by v. Now, I'm not going to show the work of plugging in. That's important to do, but I do just want to point out again here, r is the full center-to-center distance. So in my calculator, I'm going to do 2 times second pi times, what's the radius? It's 6.00402 second EE 11. And then I have to divide, 11. And I have to divide by the speed v, which is the answer above. So I do second answer. And I get let's call that 2.1, 1, 2, 3, 4, 5, 6, 7, 8. 2.1 times 10 to the 8. Seconds.